Hello everyone, welcome back to the channel The Engineering Essence. Today we are going to discuss an interview problem from Leetcode called find minimum rotated sorted array. So it is an medium Leetcode problem as it is mentioned in the label. So the problem statement is suppose we have an array of length n. So it is sorted in ascending order and it is rotated between 1 to n times. So we need to find the minimum element from this rotated array. What does this mean of rotation? Means let's say we have an array which is in sorted ascending order. So let's say I'm taking the example here. It is already written here like 0, 1, 2, 4, 5, 6, 7. So it is sorted in ascending order. So let's say I want to rotate this array one times. In our question, it is already given that 1 to n times the array can be rotated in as an input array. So let's say I'm trying to rotate this for 1 times, and what it will output is, let's say like the 0 you can see here, it will shift from its position 1 position ahead. Okay, so we will have, let's say this one, I'm going to write this one. So it will move 1 step ahead from its original position, and all the other elements will also move to ahead of its original position. So it will be formed like this one. Okay, so 7 will be not here. The 7 will be moved to the first position because we are going to rotate the whole array. So the first iteration will be like this one, not iteration. The first rotation will be like this one for the position 1. So if I do, I'm also mentioning the rotation times. It is 1 times more rotated, and the second one kind of bring this one too. So if I move it like 2 position rotation, then we have the 0 will be moved to the second position. Okay, it will shift to 2 position ahead. Then all the other element will be shifted like that. This one, like that one. Okay, so it's kind of this one. And what will happen? Of the other element like 6 will move to the initial position like this, and 7 will move. 7 will also move to like this one position ahead. So the second rotation will be look like this. Similarly, we have the 4 times rotation. We have a 7 times rotation. So in the question, the array will be in sorted order, sorted in ascending order. But only condition is that we have a rotated sorted array. Okay. So the rotation, what rotation it is, I have explained you. So we need to find the minimum from the sorted array. Okay, so we have a good property which is the element, the array is already in sorted way, so we can use an approach which will be very efficient for solving this question. And one more condition that it is mentioned, the question is the element whatever it is present in the array, it will be unique, and we need to find a solution which will be in order of log n times only. We can also find it is in order of n times, but we have to solve this question in optimized way, and should be consume only order of n log n times of time complexity. That's it. We are now going to talk about the best approach for solving this question. So basically, if I talk about the brute force approach, it will be like creating a variable and storing the minimum element by iterating the whole array one by one. So we will get the minimum element, but it will not be the acceptable approach because it will take order of n time complexity, and which is not accepted by the question. So for achieving this time complexity, we have to use binary search algorithm. So for applying binary search algorithm, what we need to do, we will take 2 pointers, okay, left and right pointers on these 2 points. Okay, so on behalf of this 2 pointer left and right, we will find the mid element. Okay, so as we need to find the minimum element, we will move our pointers, the left and right pointer, wherever we get the minimum element. Let's run our approach using this example. So I have written some condition on behalf of this one. We will run our approach. Okay, so these are the 3 conditions that it need to follow to find the minimum element. So what we will take 2 pointers L and R. Okay, left and right, you can see here. So L will point this element and R will point this element. Okay, so on behalf of this one, we will need to find the middle element. You can see the second condition, middle element formula will be like L plus R minus L divided by 2 means L plus R by 2. So we have a, if we apply this formula, we will get the index as 5 for middle element. Okay, as L plus R will be like 0 plus 4 by 2 will be equal to 2, 0, 1, 2. Okay, so the mid will be here only. After that, we will check whether our nums mid is greater than nums r or not. So we can clearly see nums mid means 5 and 2. We have nums mid is greater than 2. Okay, nums r is pointing here only. So the L will, so our L which is pointing here will be equal to mid plus 1. So mid plus 1 is nothing but this one. Our mid is here and mid plus 1 is here. So L will be point this element which is 1. Okay, so our right will as is whatever it is pointing here. So right will point this element and L will point this one element. Okay, after that the next iteration means in the next iteration we find middle element as L plus R by 2 means 3 plus 4 by 2 means 7 by 2 means 3.5. So 3.5 will be converted to integer as 3. Okay, so mid will be equal to this one 0, 1, 2, 3. So 1 will be the mid in the next iteration. Okay, so our mid is here, and then next step we will trying to apply this condition like whether nums mid is greater than nums r or not. So here it is failing, so it will goes to second else part. Okay, so r will be equal to mid. So our r was pointing this one. Next time it will pointing here only. So r is now pointing to 1, and previously L is pointing to 1 also, and our mid is also pointing to 1. So L and R is equal here, as you can see here. Okay, so our loop condition will false here, and it will exit from the loop. Okay, and once we exit from the loop, we will get our middle element as nums r. We will always return return nums r as a answer. Okay, so we have 1 as a minimum element for this example. Similarly, if I take, it is the condition for right one, and if I take the condition for left one, so this example will illustrate that one. So let's say if we want to find the minimum element in this array, so we will keep our 2 pointer left and right on these elements on this positions, and if we be trying to find the middle element, part will be like this, like the 0, 1, 2, 3, the 3 plus 0, okay, divided by 2 will be produce 1.5. okay, means 1. Okay, so 0 and 1, this will be the mid element. Okay, so we will check on which half we get the minimum. So the 11 is less than the 13. Okay, the mid one. So what we will do, we will move our right pointer to the 13, the mid element. So we have a right pointer here, and we have left pointer here. So mid element will be 11 here, because 0 and 1 divided by 2, 0 plus 1 divided by 2 will be equal to 0.5, which will indicate that the index will be 0. So this will be the mid one, and we will check our condition, and it's satisfied to the 11. So the 11 will be the minimum element. So both conditions we have seen here, like for right and for left. So that we will find our minimum element using the binary search. Okay, so this will be the approach, and so let's solve this question by using the binary search. So here we have the method find min. So what we will do, we will we'll take two variables, 2 pointers, like the left and right. I will make it as L, which will be initialized as 0th index, and we have then right, which will be initialized at the last element, which will be like the length -1. Okay, we will use while loop here, and the condition will be like the left pointer should be less than right. So L is less than R. After it will equal or exceed the limit, it will exit the while loop. Okay, so here we will also going to take an variable which is named as mid, and we will trying to find the mid element by using the formula L plus R -1 divided by 2. Okay, why we are using this one, there is a separate story, but yeah, we should use this formula for finding the mid element. It will be safe. Now what we will do, we will apply our condition that we have to. So here we got the mid element. Okay, the L plus R by 2. Okay, we have the minimum element, sorry, mid element, and on behalf of this one we will find that whether the mid element is greater than or less than the nums r. Okay, means if I take this one, so whether the mid element is greater than right element, so yeah, it is greater than right element. Okay, the mid element is greater than right element. So in this case we will have to move our left pointer to the mid one. Okay, to the mid one means we have to move our left and right pointer near to the minimum element. Okay, near to the minimum element. So L should be equal to mid plus 1. Okay, mid plus 1. So mid plus 1 means we will keep our pointer here only. Okay, so otherwise what do we need to do? Else we have to like put r is equals to mid only. Okay, when it is exit the loop, we have to return the nums r. So this will be our solution. A little mistake here. It should not be 1, it should L here. The formula should be L plus R minus L by 2. Okay, so let's run this solution and check whether it is passing the test cases or not, sample test cases. So yeah, we can see that all the 3 sample test cases is passed and executed successfully. So let's submit our solution. Check. So I have submitted the solution and you can see it is an acceptable solution. It is taken like 0 millisecond and 100% beating the solution whatever it is available on the Leetcode. So yeah, this was our solution. So guys, that wraps up today's lecture on the Leetcode problem. If you found this explanation helpful, don't forget to like the video, subscribe to the channel and hit the bell icon so you will not miss the future tutorials. Thanks for watching and I will see you in the next one. Thank you again.